Alright, this is chapter 5.4, which deals in factoring. A couple things I need you guys to know about factoring is that factoring is... Sorry, I had to type that in. Factoring is division. You are reverse distributing the things that are being inside of a polynomial. So there are a couple of different ways of factoring that I need to show you guys. The first one is factoring using GCF. Okay, and I apologize for that handwriting right there. It's factoring using GCF, greatest common factor. And all you really need to look for when factoring using greatest common factor, and this should be the first type of factoring you look towards doing whenever you're faced with a polynomial, is do the terms have anything in common? Okay? So when we look at our example here, this example 1, if I say 5k to the third p minus 3kp plus k to the third p to the fifth, you've got to ask yourself, do they have anything in common? Well, of course they do. Each term has some sort of variation of k in it. This one has a k to the third, k to the first, k to the third again. And so what we're going to do is we are going to take that out, and I'm sorry, and in fact they each have a p as well. So what we're going to do is we're going to factor out a k, because that's all I can do. I can't factor out a k to the second or k to the third, because this middle term only has one k to be removed. And then I'm going to remove a p also. Again, I can't remove anything higher than that, because this term here has 5 of them, but these terms only have 1. So I can only really pull off the lowest denominator, or the lowest exponent, in terms of my variables. So if I pull out a kp, and actually I'm going to move this down. Remember I told you guys, factoring is like division, so essentially what I am doing is I'm dividing everything by kp, which is why we learned this section last, is, or we learned the first section last, is because you need to learn how to divide your exponents. So here 5 can't divide with anything, it becomes a 5. K to the third divided by k is k squared, and the p's cancel each other out. If I subtract, I bring the subtraction sign down, these are going to cancel each other out, I get 3. The plus is going to come down, the k's cancel, I get k squared left over, and the p's cancel, I end up with p to the fourth. Okay, so that is your example of GCF. Let's do another one. If I say 12ab to the third minus 8a squared b squared plus 10a to the fifth b to the fourth, well, I have to look at what each of these terms have in common. Well, they're all even numbers, which means they can at least go into 2. Looks like 2 is as high as I'm going to be able to go, because this 10 right here can't divide into anything higher than that. Well, that takes care of my coefficients. They each have an a, so I'm going to pull the lowest a out of there, so it looks like a to the first. And then the lowest b that I can pull off is b squared. Now what does that leave me on the inside? If I divide everything by 2, I end up with 6 on the inside. The a's are going to cancel each other out. B to the third divided by b squared is b, minus 8 divided by 2 is 4, a, and no b's in this one, plus 10 divided by 2 is 5, a to the fifth minus a is a to the fourth, and then b squared. Okay? Hopefully you were able to beat me to that answer. Okay, factoring using GCF. The reason why we teach you this is for a couple of reasons. Primarily, GCF is used to factor by grouping, and that is primarily used for 4-part polynomials. So let me give you guys an example. If I said b to the third, actually this is example 1 for the next heading, b to the third minus 3b squared plus 4b minus 12, well, what I'm going to do is I'm going to group this 4-part polynomial into two-part polynomials. And from here I'm going to go greatest common factor on the first grouping and then greatest common factor on the second grouping. So here it looks like I can pull off a b squared, and what I'm left with on the inside is b minus 3. I have a plus, I can pull out a 4 here, so I pull out a 4, I get a b minus 3. Now, you should, whenever you're doing factoring by grouping, end up with duplicates. And what's going to happen is that now that I have one of these duplicates, one of the duplicates can actually factor out again. So I end up having b minus 3 times b squared plus 4. All right, that is your factoring by grouping. Let's take on something a little bit harder. Let's go a squared x squared minus b squared x squared. Sorry, not b squared x squared. B squared x. Sorry, I made a mistake in writing that example down. It's a squared x minus b squared x plus a squared y minus b squared y. Okay, again, I'm going to group. I can factor out an x. From the front runner, I end up with a squared minus b squared, plus I can factor out a y here, and I end up with a squared minus b squared. Again, I should end up with duplicates here, right? So what I'm going to do is I'm going to factor out an a squared minus b squared, and then x plus y is what's remaining. Now, some of you guys are hotshots and know that you can refactor this. We're not quite there yet, but if you want to refactor that into a plus b times a minus b, go for it. Okay, so let's go ahead and take a look at what we're doing next. Factoring trinomials is basically the part of this lesson that I want you guys to hammer in the most. Now, this should be review for a lot of you guys, and factoring is actually what I consider to be, or factoring of this kind anyways, it's what I consider to be one of the most important concepts in algebra that a lot of people tend to miss. And basically this thing, what I need you guys to get comfortable with is I want you guys to get really, really good at guessing. All right, and believe it or not, you will get better. Your instincts will get better as to what numbers you can choose. But the bottom line with factoring a trinomial is that you need two numbers that multiply to equal the end number, and then they need to also add or combine by, let's just say sum to the middle. Now, the more important one is that they multiply to get to the end, because when you start throwing a coefficient out here, things can get a little messy. So the most important aspect is that the two numbers that you choose multiply to the end. So what we're going to do is we're going to split apart x squared into x and x into my two parentheses. My signs here are double positive, which means that they're going to be double positive on the inside. And I need two numbers that multiply to 9 and add to 10. Well, that's simple. It's 9 and 1. All right? And again, all that it really takes with factoring a trinomial is lots and lots of practice. You have to do thousands of them. So I'm going to divide this out, x and x again. That's where my x squared comes from. And then I need two numbers that multiply to negative 10 and add to negative 3. Well, 5 and 2 can produce a 3 as long as one of them was negative. Well, I'm looking at a negative 3, which means that 5 has to be negative and 2 has to be positive. How about something like y squared plus 20y plus 96? Again, y's are going to get split apart. I have double positives, which means my symbols are going to be easy. I need two numbers that multiply to 96 and add to 20. That is 12 and 8. Again, you just have to keep doing a bunch, and then eventually your combinations start getting a little faster. If I say 2x squared plus 3x plus 1, now 2x squared has to be divided into 2x and x. Again, my symbols are double positive because they're double positive here. And now I need two numbers that multiply to 1. Well, that's a piece of cake. It's 1 and 1. Number 5. 2a squared plus 13a minus 7. Here's where it's going to get a little bit tricky. I got 2a and a. My symbols are going to be plus and minus, but I don't want to know. I want to know what order I'm supposed to put them in, because that's actually going to matter. Let me try 7 and 1, because those are the only two numbers that will multiply to 7. Well, I can go ahead and check. I've got 2 and 7. When I combine 2 and 7, I get 9. That doesn't help me. So let me try and reverse the order. If I put a 1 here and a 7 out here, I've got a 14 and I've got a 1. Well, 14 and 1 can get me to 13 as long as 14 was positive and 1 was negative. So that is my factor right there. Again, you're going to be doing a bunch of these for your homework tonight, so you will have plenty of time to practice. Is difference of two squares. Again, this should be mostly review for you guys. If I give you something like x squared minus 9, you should hopefully know that it's equal to x plus 3 and x minus 3. I've got a perfect square in x squared, I've got a minus sign, and I've got a 9, which is a perfect square. Hence the name difference of two squares, right? The subtraction sign indicates that it is a difference. If I say x squared minus 16, that is going to be x plus 4 times x minus 4. It doesn't matter what order you put the plus or minus in. If I say x squared minus 121, the only way things can get a little harder is if they start giving you numbers where you don't know the square root of that number. For example, if I gave you x squared minus 196, some of you guys may not know that that is x minus 14 and x plus 14. All right? So that's the only way they can really make it harder. They can throw other variables in there. They can say x squared minus, say, 144y squared, but that will simplify, or that will factor into x minus 12y and x plus 12y. All right? That's the only way they can really make it harder. Let's just do one more. Let's say x squared minus 36y squared. Again, same deal. X plus 6y, x minus 6y. All right? Sometimes you're going to have to factor more than one time in each problem. For example, if I give you guys k to the third minus 2k squared minus 3k. Well, this looks like a trinomial, and it looks like you should be able to get it here first, but what's happening is that you've got k's and everything, so you're going to have to resort back to GCF first. And then you've got k squared minus 2k minus 3, and now you are ready to handle this thing. It's k minus 3 times, oops, not x, k plus 1. All right, so sometimes you have to factor, then refactor. 6a squared plus 27a minus 15. Here, they each seem to have a 3 in common. So if I factor out a 3, I end up with 2a squared plus 9a minus 5. And that's going to factor into 3 times 2a minus 1 times a plus 5. All right? Number 3, here comes a difference of two squares version of this. If I decide to factor out this difference of two squares, I end up with m squared minus 1 times m squared plus 1. Now this m squared minus 1 can refactor into m minus 1 times m plus 1, and then m squared plus 1. You can't factor this thing because it's not a difference, it's a sum of two squares. Sum of two squares. Ooh, let's do something really, really messy. 7mx squared plus 2n x squared minus 7my squared minus 2ny squared. This one's kind of cool. Remember, 4-part polynomial? Think about factoring by grouping. So I can factor out an x squared from the front runner. I get 7m plus 2n minus, I can factor out a y squared from the behind terms. 7m minus 2n. Oops, I'm sorry, it should be plus. It should be plus because when I redistribute the negative, it'll become minus. My bad. Well, I'm going to refactor out the 7m plus 2n, and what I get is 7m plus 2n times x squared minus y squared. And now I can refactor the right term into x plus y times x minus y, and then 7m plus 2n. All right? Cool. Next little section. All right, it is time for Little Bro, Big Bro, which is what I refer to, or rather sum and difference of cubes, which is what I refer to as Little Bro, Big Bro. Now, the one thing that I want you guys to keep in mind is that it is called sum and difference of cubes. So it's similar to difference of two squares, except now you can actually use it when there's a sum happening, and I'll show you what that looks like. Here, I have a to the third minus 8. The first thing I want you to do is I want you to reduce each of these into something that looks like it's being cubed. So what I mean by that is a to the third is still going to be a to the third. Subtraction is still going to stay subtraction. 8 can be rewritten as 2 to the third power, right? Because 2 to the third power is 8. And what I'm going to do is I'm going to draw little bro, and then I'm going to draw big bro, because little bro is a binomial, and then big bro is a trinomial. All right? Well, little bro gets one of each thing. So what I get is a minus 2. It's an exact replica of what we see up top here. Well, what happens is that when I take an a minus 2 out, what I'm left with is a squared minus 2 squared, right? Because I took one, right, these become 2. Well, big bro gets the a squared here. It also gets the 2 squared here, which is 4. The middle term is the multiplication of little bro. So what I get is 2a. Now the symbols for big bro always follow this pattern. It goes opposite of little bro, and this one is always positive. All right? So I know that's kind of a tricky thing to kind of get used to. And little bro, big bro is one of those things that I just feel that you have to memorize, which is something that I rarely try to say, but you just have to memorize how to do this. And after doing a few hundred of them, you'll start to get how it goes. And so we'll just do a lot of these, and they'll show up in your worksheet a lot. Little bro, big bro. And so, yeah, let's just do it. And if you want to recheck, you can refoil this, and you'll get a to the third minus 8. If I say x to the third minus 64, well, I'm going to draw my little, oops, no, I'm not going to do that yet. I'll do this step by step first. This is x to the third minus 4 to the third. Little bro, big bro here. First little bro gets x minus 4, and that reduces this into x squared minus 4 squared. Well, big bro gets an x squared, and it gets a 16. The middle term is going to be little bro multiplied, so 4x. And then opposite little bro is positive. Big bro is always positive in the end, and that's as far as you go. Do not be tempted to refactor big bro. You'll never be able to do it. All right? It's a prime trinomial. So if we were to ever solve this, you would need to use the quadratic formula on that one. Let's take a look at a sum. X to the third plus 27. So let's go ahead and go x to the third plus 27 is 3 to the third. So I got little bro and I've got big bro here. Remember, little bro just gets one of everything. X plus 3, it's a replica, except it's 1, exponent of 1. Well, this gets an x squared and this gets a 9, right? Because when I take out 1x and 1, 3, I get x squared plus 3 squared. The middle term is going to be 3x because that's little bro multiplied. Now, opposite little bro is going to be minus this time, and big bro is always positive on the end. See if I can do this one faster without you guys hopefully getting messed up here. X to the third plus 216. The only tricky part about this is knowing what 216 is in terms of something being cubed. It would be x plus 6. And this is x squared, 36, 6x, opposite, positive. Done. And done. The only way they can really make it harder would be to throw coefficients in front for you. So if I gave you, say, 20, oops, we're on number 6 now. 27x to the third minus 1. Well, let's take this one step at a time. This is really 3 to the third, x to the third minus 1 to the third, right? And I got little bro and I got big bro. Little bro is going to get a 3x minus 1. Big bro is going to get, well, that's going to become 3 squared x squared minus 1 squared. Well, that's a 1, that's obvious. This is 9x squared, and now the middle term becomes 3x, right? Because I'm multiplying little bro together. Opposite, positive, you are done. Whoa. not straight a line. So let's try another one. 125x to the third plus 64. See if we can do this without reducing anything. It looks like I've got a 5x plus 4 for little bro. Big bro is going to be 25x squared. This is going to be 16. 5 times 4x is 20x, opposite positive, and that is as far as you go. Cool. That's all I got for you guys. We'll see ya.